Hi, in today's video I'm going to show you what is the real cost of returning the identity value in EF Core. Let's explore the existing SQL Server database. When user creates an order, he creates a product card. Each product card has many product card items that are related with products. Let's explore our codebase. You have a product entity, a product card entity, and the product card item entity. I have prepared a benchmarks project. Let's run our project in the debug mode and see what a problem we have here. Here we insert 10,000 products to the database. As you can see, when we insert our products, we don't have any IDs assigned because we have an integer identifier column, and in our mapping we have specified to use a database generated value. So we are using an identity column in the SQL Server database. Okay, after executing save changes async method, we can see that our products now have all IDs assigned. And this costs a lot of performance. Now let's run our benchmarks in the release mode and see how much time it takes to insert 10K records to the database. I have prepared a small benchmark. In the setup method, I create the database context with SQL Server database, and in the benchmark method, I insert 10K products. Important note, you need to specify the connection string to the SQL Server database in the benchmarks project. Now let's run and explore the performance. Okay, the results are back, and as we can see, save changes method takes about 363 milliseconds to execute. Why save changes async method is really slow? In many databases, EF Core batches multiple inserts into a single command, but the database still executes this insert one by one. For SQL Server, EF Core uses a merge statement to insert multiple rows at once, but EF Core's approach is limited by the number of SQL parameters. It's 2100 per batch, and the performance drops quickly when entities have many columns. That's why I want to introduce you to Entity Framework Extensions library. This library offers simpler, more elegant and configurable options for bulk inserts that allow inserting thousands of records very fast in a single database call. This library supports various database providers such as SQL Server, Azure SQL, Postgres, SQLite, Oracle, MySQL, and MariaDB. It offers a lot of methods for bulk operations, but like BulkInsert, BulkUpdate, BulkDelete, BulkMerge, and BulkSynchronize. Let's add this library to our solution. I'll open the NuGet and we will need to install this library Z Entity Framework Extensions EF Core. Let's install it in the benchmarks project. And let's create another method for bulk inserts. I will call it BulkInsert async. And instead of calling database context save changes, I will use the BulkInsert method and provide our products. Now let's run our benchmarks and compare the performance. Alright, the results are back. As you can see, we have improved our performance more than in 3 times. Let's explore how this BulkInsert method works. In our program CS of benchmarks project, I will write the DB context BulkInsert async and provide our products. And let's compare how it works to save changes. Okay, before insert, as you can see, we have no IDs assigned. And when we perform BulkInsert method, we can explore that we have IDs assigned. So when the SQL Server inserts our products, it generates IDs with identity, and EF Core Extensions library returns these IDs. In many cases, you may don't need these IDs that are inserted to the database. If you don't need IDs, we can experiment and use the BulkInsert optimize async method. Let's run and see how it works. Okay, let's insert our products. And as you can see that after insertion, our IDs columns are still 0 and not assigned. And this method will work much faster than the BulkInsert method. In the official documentation of Entity Framework Extensions library, this method doesn't output values by default. This means that BulkInsert optimize method won't assign your properties with values that are generated by the database. For example, it can be identity columns and some columns with default values created during insertion in the SQL Server database. This method is also very useful as it returns some bulk optimized analytics response object. It tells you whether the bulk insert is optimized, and if not, you will receive some tips to make it optimized. For example, in this case, bulk insert will not be optimized as this insert if not exist options can be handled directly by SQL bulk copy. So it requires an extra logic with a temporary table to insert our entities. So when we use bulk insert optimize method, our insert can be optimized. The EFCore extensions library inserts directly into the destination table without using the temporary table. Let's update our benchmarks and see how this optimized method performs. I will use the bulk insert optimized method and let's run our benchmarks. Okay, the results are back. As you can see, the bulk insert takes about 95 milliseconds and the optimized version takes 66 milliseconds. This is a pretty significant improvement. Now let's explore a more complex example when we will insert a graph of objects. I have prepared the small code snippet that creates a product card. Here we create products and we create the products card. Each product card contains a user and multiple card items with products. In this case, we emulate the business use case when the user creates an order for the first time in the online store and his profile is created with his order at the same time. And let's create some benchmarks here. I will create a new method and call it insert graph. We will generate 10,000 product cards and insert them. Now let's add two more methods. One method will use insert graph bulk insert a thing. We'll create 10k product cards and call the bulk insert method from the Entity Framework extensions. Insert a graph object in the bulk insert method, you need to call and specify the options and include the include graph option and set it to true. Now let's create the same benchmark for the bulk insert optimize method. Here we'll call the bulk insert optimize method on the DB context, rename the method, and specify the same include graph option. Let's run our benchmarks and see how it performs. Alright, the results are back, and as you can see when inserting the graph of objects, the bulk insert method performs much faster with the same changes from the EF core, and the bulk insert optimized version is even faster. So this is the cost you pay for returning your identity values. When you don't need to use your identity values after inserting your entities, I highly recommend using Entity Framework Extensions library with bulk insert optimize method. Now a few words about licensing. EFCore Extensions is a paid library, but it offers a free trial. Each month you can extend your free trial and update the Entity Framework extensions EF Core library to a new version. You can use the free trial to test this library, its features, and see if it fits your project needs. Then, for commercial use, you need to buy a license. Thank you for your attention.